Hello, in this section we're going to look at graphing linear inequalities. Now, when it comes to a linear inequality, we have that it must be of the form ax plus by is less than or equal to c. Now, in this sense, we have that there's many different types of other inequalities that you might have. So with this, notice that this is almost like an equals symbol right here, except we have that it's less than. Now, make no mistake that you may actually include the greater than, less than, greater than or equal to, and then of course you see the less than or equal to symbol. So one way of which that we can look at this is by considering when we have 5x plus 2y is less than or equal to 10. Now, one of the ways of which that we can graph this equation is by looking at the x-intercepts and the y-intercepts. So to do that, we can consider the following equation. So we look at its form where you have 5x plus 2y is equal to 10. Now, the only reason that I'm doing this is because this is what I call a boundary line, and it's going to help me basically find like the form of the inequality. So we look for the x-intercept, and the way of which that we'll do that is by using algebra. We'll just say that, well, an x-intercept is when the y is set to 0. So what that means is that you have 5x is equal to 10, which basically tells you that x is equal to 2. So hence that means that you have that the x-intercept is 2, comma 0. Now, if we go ahead and we look at the y-intercept, well, the y-intercept is actually more or less the exact same thing. You have that instead, the x is equal to 0, and that gives you that 2y equals to 10. But that tells you that the y has to be equal to 5. So now you have the ordered pair 0, comma 5. Now, this is basically enough to graph this equation, because we have both of the two ordered pairs that define the boundary line. So let's go ahead and just draw. Now, of course, what we can say is, for example, that we have 2, 0, and then maybe we'll have 5, 0 right there. Now, we need to form the boundary line, so let's go ahead and form the boundary line. Well, the boundary line just has to pass through 0, 5 and 2, 0. So let's go ahead and do that. Okay. Okay, this should be good enough. So let's go ahead and draw our boundary line. Okay, so we have our boundary line, and for here, we can actually notate, for example, that this is the boundary line that we mentioned, 5x plus 2y equals to 10. Now, of course, keeps going, and that keeps going. But now the question becomes, like, how do we find the shaded region? So to find the shaded region, normally you just need to pick a test point. So we have that you can pick a test point that's either above the line or below the line. As long as the origin is not contained, then in that case we can use the origin to test the inequality. So we have that we're going to test 0, 0. Now, when we plug in 0, 0 into our inequality, we have 5 times 0 plus 2 times 0, and that's going to be less than or equal to 10. Now what this does is it tells us that 0 is less than or equal to 10, which is in fact true. Now, due to the fact that this is true, that means that we have that the shaded region is going to be everything that's below the boundary line. Now, to kind of understand that, that means that the solution region lies below the line. But here's another name that we actually call the shaded region. This is actually known as the feasible region. And to be more specific, we actually say that it's unbounded. It's unbounded due to the fact that you have that it just keeps going and there's many solutions that lie below here. Now, keep in mind that if you would have picked a test point, let's say for example you picked a test point that was out here, then most likely that would have gave you a false statement. So just be careful with how do you find the shaded region. So we have that the next thing that we can do is look at the different forms of inequalities. So we have that essentially if you can get the inequality to be in the format of y equals mx plus b, this is actually a lot easier in terms of finding the shaded region. So like if for example you have y is greater than or equal to mx plus b, this actually means that you are above or on. But if you have that y is less than or equal to mx plus b, you have that this is going to be below or on. Now, furthermore, like if you can rewrite your boundary line in this format, so again, this is the boundary line. If you can get it in this format, like let's say like it's greater than mx plus b, well, the only difference is that it's above. And then if you have that y is less than mx plus b, that actually says that it's below. So these are the different formats that you would have without having to use test points. So let's actually look at some examples of finding the feasible region. So let's say that we want to graph 3x plus 2y is greater than or equal to 18. So to do this, we said that we just need to find the x-intercept. So the x-intercept is where the y is equal to 0. But keep in mind that the boundary line is 3x plus 2y equals to 18. So what this does is it tells us that we have that the x-intercept, if x is equal to, if y is equal to 0, that means that the ordered pair has to be 6, 0. Now, in case you're wondering, like, how did I get that so fast? That's because you're taking 3x and you're setting it equal to 18, which gives you that x is equal to 6. Similarly, we can find the y-intercept, of which this will tell us that we have that the y-intercept is going to be 0, 9. So again, if in case you're wondering like how did I get that so quickly, then in this case that's just 9y equals to 18, which tells us that y is equal to 2. Actually it's backwards, isn't it? Yeah. Yeah, this should be a 2. Okay, so yeah, that's going to be a 2, and this will be a 9. Okay, now if you want to basically graph this inequality, you can. The way way of which that you can do this is by going ahead and graphing the two boundary points. So you have that the first one is 6, 0, so you have 6, and then you have 9. Now, all that we need to do here is just connect these points, and then the next would be to pick the test point. Now, conveniently enough, we have that 0, 0 does not pass through the boundary line. So we have that we can actually test 0, 0. So notice that you plug in 0, 0, and you get 0 is greater than or equal to 18. But this is actually false. So in this case, this would imply that the shaded region would actually be the opposite end, or the opposite side. So we're just going to shade over here and over here. And of course, we have that this is our unbounded feasible region, but this is our shaded region nonetheless. Now, another way that you probably could have done it without using, say for example, using the testing method, is that knowing that you have 3x plus 2y is greater than or equal to 18, you can actually rewrite it in a way that you just have that y is by itself. So you have negative 3 halves x and then plus 9. Notice that this is basically telling me that I'm above or on. Now, what I normally tell people in class is that if it's positive and it's greater, then automatically I know that it's above. But if it's negative and it's greater, then it's the opposite, because you have that it's going to be that this is going to flip. So there are many different ways that you can actually come up with, like your own different ways of like finding the shaded region. Okay, now, really quick before I move on, now, if your inequality is of the form, let's say like ax plus by, and let's say that it's equal to c, this is the boundary line, then for those that would like a more formulaic approach, you can actually just say that the x-intercept is c divided by a, comma 0, and that the y-intercept is just 0, comma c over b. Now, of course, this is provided that both a and b are not both 0. Okay, so in this case, like even if it is like a vertical line or a horizontal line, then it's just as long as they're both not 0. Okay, now let's say that, for example, that we look at systems of inequalities though. Now, whenever we look at systems of inequalities, essentially it means that we're just graphing multiples. So let's say that we want to graph x plus y is less than or equal to 4, and then we have x minus y is greater than or equal to 2. Now, what this means is that basically you would just need to find that you have different sets of x-intercepts and different sets of y-intercepts, and also a set of intersection points. So one way of which that I can do this is that I know that for, say for example, inequality 1, that the x-intercept is 4, comma 0, and that the y-intercept is 0, comma 4. Furthermore, I know that with the second inequality, that the x-intercept is 2, comma 0, and that the y-intercept is 0, comma negative 2. Okay, now in this case, all that we need to do is just graph these inequalities. So we'll go ahead and graph these inequalities. as follows. Okay, so we have that. Let's go ahead and graph the first inequality. So we have that we just need 0, 4, and then we need 4, 0. So let's just make this 4, 0, and we have that it needs to look something like this. Okay, now we also need 2, 0. Okay, so we have 2, 0, and then we need 0, -2, which we'll put it right there. So here is what that's gonna look like approximately. So here's our here's where we need to go ahead and label some things. So for instance, I know that basically this is the boundary line x plus y equals to 4, and I know that this is the boundary line x minus y equals to 2. Now, the next part that we need to figure out basically is this. We need to figure out what is the point of intersection. So the point of intersection is found by looking at the lines x plus y equals to 4 and x minus y equals to 2 and solving it like a systems of equations. But you can kind of tell that if you basically use elimination or substitution method, that essentially you're going to get that the ordered pair that they pass through is 3 comma 1. Okay, now you can use that by finding, whether it's using your calculator or using elimination method or even substitution method. But the main thing is that you want to make sure that they actually do intersect, because if they don't, then you'll notice that there really wasn't anything to do. So that's 3 comma 1. Now the other part of this is that you need to figure out where to shade. So in order to figure out where to shade, notice that this is negative and this is greater than, but in either case all that means is that you're going to be below the line, because if you plug in 0, 0, you still get a false statement. Or, like I mentioned, if it's negative and it's greater, then it's the opposite. It's going to be below. So I know that it's going to be below, 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 and below. But then over here, this says less than. So this is going to be simply just below the line. But what you want to do here is really just shade the region where it's overlapped. So in that case, you have that the overlap is going to be just right over here. The overlap is going to be over here, where it's bounded by these two boundary lines, but you have that overall the feasible region that we have here is unbounded. So I should maybe shouldn't have used the term bounded by the boundary lines, but we have that it's still considered to be unbounded. Okay, so this is the shaded region that lies beneath the curve. Now, you do have that in some cases, you're going to have that there are a feasible region that's restricted to, let's say, a particular quadrant. Okay, so suppose that we have a set of inequalities like 2x plus 3y is less than or equal to 54, and then let's say that we have 5x plus 4y is less than or equal to 100, with that x is greater than or equal to 0 and y is greater than or equal to 0. Now, what I'll say about these last two restrict you basically to the first quadrant. So just recall that, when you're talking about quadrants, you're talking about that you have 1, then you have 2, then you have 3, and then you have 4. So that means that it's restricted to the first quadrant. Now, since I basically want to graph this, let's do this in a way that we don't really have to do too much work. So we have that basically you have that 2, let's label these actually respectively. So you have 1 and then you have 2. Now with the first inequality, you know that it's going to be such that the x-intercept is basically going to be 27, 0, and then you have 0, 18. Now for the second inequality, you have that it's going to be, let's see, you have 25, 0, and then you have, actually, it's not 25, 0, but it's 20. So you have 20, 0, and then you have 0, 25. Okay, so essentially all that we need to do is just plot these 2 points. Okay, so let's say that we graph the first one. So we have 20, 0 and 0, 25. So 0, we'll just say that this one right here is 20. Okay, so that means that this will have to be 10. And then if we keep this going, then yeah, 27, roughly, let me see, 25, 27. Okay, so let's just extend this a little bit. Okay, so the next thing that we have to do, okay, so this is 0, 25. And then we need 18. So maybe like right about here. Okay, so we have that we just need to plot 27. So let's do this actually with a ruler. Okay. Okay, that might be good enough. So, okay, let's just start right here. Okay, now what we're going to put here is that this is 27. Okay, now here's where it gets a little interesting. Now, we know that we're restricted to the first quadrant, so we have that 0, 0 is kind of like a boundary point. And then we have that there's a point of intersection right about here. And then furthermore, we have that there's these points right here, right here, right here, and right here. Now, of course, if you're wondering like how did we get these points again, you had to plug them in to find the x-intercept and y-intercepts respectively. Now, the other thing that you'll have to do is you'll have to realize that the shaded region for each of these is such that, okay, well, the first one says that it has to be below, and the second one has to be below too. but notice that x is positive and y is positive. So basically that means that we have a shaded region that looks something like this. Now again, we're only looking for where they overlap, which they happen to overlap right here. So what that means is that we have that this is our feasible region right here, but remember that we actually have a name for this. What is it called? Well, it's bounded. So we have a bounded feasible region. Now, we also can label respectively what is called corner points. So for example, let's say that we go ahead and we label this as A, B, C, and D. Well, we say that A, B, C, and D are what we call corner points. Okay, now notice that we know what A is. It's 0, 18. Okay, so we have our corner point over here, and then we have that B is 0, 0. So let's actually just write them out. So we have A is 0, 18. We have that B is 0, 0. We have that C is 20, 0. And then D, we actually don't know what D is. Okay, so what D happens to be is the point of intersection. So again, I was mentioning something about like how you can use systems of equations. So like 2x plus 3y equals to 54. Then you have 5x plus 4y is equal to 100. Now, in this sense, what we can do is many different things to solve for the point of intersection. The point of intersection is found by either using a calculator or using a maybe even Desmos. But let's say that we go ahead and we augment the system. So we have 2, 5, 3, 4, and 54, and 100. Okay, well, suppose that we go ahead and we say, well, let's go ahead and multiply the top row by 5 and multiply the bottom row by 2 and make that a new row 2. So what that does is it gives us the following. It gives us that we have 2, 3, 54, we have 0, but then you have 7, sorry. So you have 7 because 15 minus 8 is 7, and then from there you have, let's see, you have 54 times 5, which is equal to 270. So that means that you have 270 minus 200, which is equal to 70. So we have 70. Okay, now we can solve by dividing by 7 or multiplying by 1/7. But notice that that gives you 2, 3, 0, 1, and then it gives you 10, and then 54. Now, I'm going to go ahead and just say that I have 2x plus 3y equals to 54. But what was y equal to? It's equal to 10. So I have 2x plus 3 times 10 equals to 54. Now, what this tells me basically is that 2x is equal to 24, which means that x is equal to 12. So we have that the ordered pair, or the point of intersection for our boundary lines, is the following. We have that the ordered pair is 12, 10. So we'll just go ahead and go back over here and then just label that as yeah, as 12 comma 10. Now, of course, my scale is a little off. Let me just go ahead and erase this right here. Yeah, let me just go ahead and erase that. And I'm just going to put right here that that's going to be the ordered pair 12 comma 10. Okay, now now keep in mind that you could have solved for the point of intersection by simply just going to, like, say for example desmos.com. So we can type in the equations as either boundary points or boundary lines or inequalities. So, like, for example, we have 2x plus 3y equals to 54. Now, if we go ahead and we look at our boundary lines, notice that we already have the point of intersection 12, 10, 20, 0, and the other corner point 0, 18. But it doesn't include the origin, and that's just because of the fact that, we didn't draw like x equals to 0 and y equals to 0. But note that if you did put the less than or equal to symbols, that it will give you the shaded region, but notice that it's going to be like a bit of like an overlap in this case. But at least it's better than nothing, that you have that its feasible region is right here. Okay. Now, what you'll basically need to do as it relates to further applications of inequalities is you will need to practice in terms of finding the feasible region, like whether it's by test points or by just looking at it, which, I mean, more or less it's either or. It's either below or it's either above. So, you can't get more complicated than that. Okay. And then, of course, like if you're gonna label corner points, notice that 0.25 is not a corner point. Why? Because it's not in the feasible region. 27, 0 is also not a corner point. Why? Because it's not in the feasible region. So when we get into some applications, you're gonna note that basically you can solve most applications by just graphing the feasible region. But once we get into chapter 4, that's where we may not be able to use the we may not be able to actually use like the feasible region. But for now, go ahead and practice different inequalities. Now, it is possible that some of these lines might be horizontal or vertical, so do look at that when it comes to graphing feasible regions. Now, of course, you don't need to use this either, technically, because you might actually use desmos.com, or you may actually use maybe like a graphing calculator, which in this case, the process is that you would actually just put in the equations as y1 and y2, and then you would just go to second trace intersect. Okay, but make sure that, at least when it comes to showing work and stuff like that, that you do indicate like what did you do to find the points of intersection, or even how did you find the boundary lines. Okay, so that's going to be it.